We've seen how quickly electric cars are replacing petrol ones. So it makes sense to assume that the same thing will happen with trucks. Just wait for the batteries to improve, build some chargers, and we're there, right? The technology already exists. There are battery electric trucks on the market today that can drive 500 kilometres between charges, fully loaded. That's more than enough for most freight journeys, especially considering that drivers are legally required to take breaks about that often anyway. So you can just charge during those breaks. Battery costs are coming down, ranges are going up, and electricity is cheaper than diesel. It looks like the same pattern that we've seen with passenger EVs. Once the economics tip in the right direction, adoption will follow. That's the opinion I hear all the time, and it's what I used to believe too, until I started speaking with Professor David Cebon from Cambridge University, who's been researching transport decarbonisation for decades. Now I understand that this idea that battery trucks can just quietly slot into the existing logistics system is completely unworkable. It simply cannot happen that way. When it comes to freight, the devil is in the details. And to talk us through those devilish details, let's cut to an interview I filmed with David while I was in the UK recently. We talked about why electrifying trucks is so much harder than it looks, from megawatt scale grid connections at every warehouse to the vanishing opportunities for charging as automation takes over, and what kind of radical rethink might be needed to make zero emissions freight actually work. I'm Rosie Barnes, an engineer with 20 years experience developing clean energy technologies and founder of Payload Consulting, who provide advice to clean tech startups and investors. Welcome to Engineering with Rosie. We've already got battery electric trucks that can do long distances with a full load. So on paper, it looks like the solution is already here. But what happens when you dig into the numbers and look at how freight actually works in practice? That's where things start to fall apart, starting with a challenge you may not have properly considered.
Electric trucking is a straightforward thing. The technology is essentially there, but there are some challenges with that. The logistics industry runs on very tight margins of 2 or 3%. Any additional costs have to fit within that 2 or 3%, or someone else has got to pay for it. So that means that there's a really tight constraint, and that is that stuff has got to be moved at the same cost in the electric future as now. Well, there's a few reasons why that's a difficult thing to do. Battery electric trucks weigh more than diesel trucks. Biggest articulated vehicles are 44 tonnes, of which about 29 tonnes is usable for payload. The biggest of the electric vehicles can carry 42 tonnes, of which 22 is payload. So you've lost 29 minus 22, 7 tonnes of payload. That's a quarter. If you want to transport, say, 100 tonnes of sugar or cement or oil or steel or construction products, you need basically 3 trucks, whereas electric trucks, you need 4. So it'll cost about 25% more to do that with an electric truck. So that's the first problem, is a payload penalty.
Honestly, David, a 25% payload penalty doesn't exactly sound insurmountable. Battery chemistries are improving all the time. Weight and cost reductions will probably get rid of that penalty in the near future. This sounds more like a today problem than an actual showstopper. Can the cost of battery-powered trucks come down enough that the payload penalty won't matter as much? Could it win out economically over diesel?
I mean, there's no doubt that batteries will get a lot better. Energy intensities will improve enormously. Some commentators think that they're going to get super light. I think it's very likely that battery electric trucks will get to the same price as diesel once the manufacturers had a chance to earn back some of the huge development costs, R&D costs, and battery prices come down and battery technology improves. Companies turn over, a seventh of their fleet every year or something like that. So what they're looking to do is to buy the next 500 trucks for their fleet or next 100 trucks for their fleet this year. And, the very simple equation is, can that set of 100 trucks that I want to buy this year, or however many it is, can they do the job at the same price as the diesel trucks? If they can, you can buy the electric trucks and you can run them. We are in a transition. We don't have to do the most difficult logistics job to start with. So what you're relying on there is starting with easy stuff that you can do now. Journeys that carry less than 22 tonnes, which can fit without that payload penalty. So you're carrying lightweight goods, you're carrying cornflakes or washing machines or sofas or something like that, a couple of 100 kilometres to it, 300 kilometres round trip. And if you have that kind of journey and you can charge within an hour back at base, which is doable, then you can do that at the same logistics cost as diesel. And so then your ownership cost argument is about the capital cost and the running cost. You've got a more expensive truck at the moment, but electricity is cheaper than diesel. If you run for long enough, if you run 2 or 3 shifts a day, you can just about make that pay now. And as range gets better or the truck gets lighter, as charging infrastructure starts to be distributed better, you will be able to do more journeys and buy that next 100 trucks, which can do not this really easy one, but a slightly less easy one.
Okay, to be honest, at this point in the interview, I was surprised by David's optimism. This is all sounding very doable, nice and incremental, and conceivably without a large cost penalty for logistics companies who electrify. The first problem, the payload penalty, isn't really a showstopper. What's next?
Second problem is that there is a time penalty with charging. Trucks will drive for about 4.5 hours, and then they need to stop the charge for an hour. So 1 hour in every 5 needs to be spent charging. Drivers, they do have to have a break actually after 4.5 hours. They have to have a 45-minute break. You could use the 45-minute break to charge your truck. In practice, what actually happens is that they happen at warehouses and at distribution centres when the trucks are picking up and dropping a load. So what that means is you have to get your electricity for charging to the points where you're picking up and dropping your load. A truck needs probably 600 kilowatts, and you might have a warehouse with 50 loading bays. Perhaps half of them are in use at any time, 12.5 megawatts in one warehouse. And there are tens of thousands of those facilities around the country. And that is not straightforward at all. 20 megawatts is enough to power a town. So the alternative is to charge by the side of the highway at motorway surfaces. If you add an additional stop, then you're adding an extra hour out of every 4, adding another 20% to the cost because you've got to pay for the truck and you've got to pay for the driver while it's sitting and charging. Even if they have really fantastic batteries, a quarter of the weight of an existing battery, you would either put 4 times more of them in your truck so you could have 4 times longer range, or you might have a much lighter truck with a shorter range. But whatever you do, you still have to put the energy in the warehouse. If it's got 4 times bigger battery, you've got to put 4 times more energy, and that will mean 4 times more power. Instead of charging at 600 kilowatts, you'll need to charge at 2.4 megawatts to charge that battery in the same time. So the fact that you've got bigger batteries doesn't solve the problem that you still need to provide the energy.
All right, this is the point at which the penny drops for me. The problem isn't the range of the battery, it's charging. And specifically, how will that charging fit into the highly optimized logistics without smashing through that 3% profit margin that the logistics industry runs on? Essentially, you're either going to have to pay for the truck and driver to wait around charging at a roadside charger, or every single warehouse in the world needs to get a grid connection big enough to power a small town. No matter how battery technologies improve, no matter what range electric trucks are eventually able to reach, there will always remain the challenge of needing to spend time recharging in a location that has a big enough grid connection to get megawatts of electricity into multiple trucks at once. By now, we all know how challenging grid infrastructure is to build and how grid connections are the #1 challenge for energy project developers. Does anyone seriously think it's plausible that warehouses are all going to be getting multi-megawatt grid connections now? I hate to say it, but I really struggle to see this getting solved within the next decade or 2. So what is the solution? Have I been wrong to discount hydrogen to solve this problem? So people were right then when they said that it's got to be hydrogen.
Well, it's an interesting point. Hydrogen trucks, I'm afraid, aren't going to work. They're even worse from a cost point of view. So the capital cost of a hydrogen truck is very high, at least double. By far the most expensive bit of the hydrogen truck is the fuel cell. And on the electric truck, it's that battery which is coming down in price really fast. It means that hydrogen trucks will always be way more expensive than electric trucks. So that's the capital cost. On the operating cost, hydrogen is very expensive. And there's been a lot of stories about how cheap hydrogen is going to be, which really haven't panned out. Over the last 10 years, we've been listening to the fact that hydrogen is going to be $1 a kilogram. Actually, it's $10 a kilogram or more, and it is showing no signs of coming down in price. It's very difficult and expensive to make. It uses a lot of energy to make. It's very difficult and expensive to transport around and distribute, and it's very difficult and expensive to use on the vehicle. So cost per kilometre will be at least 3 times more.
Okay, so not hydrogen, not huge batteries in trucks that either charge at roadside chargers or at warehouses. Surely there are some technology developments happening that will make this challenge surmountable.
There's two other things that are happening. One is that we're going to gradually, or actually probably fairly quickly, have autonomous trucks. If you have an autonomous truck, you eliminate the driver from the equation. Now, the driver is 40% of the cost of running a truck, and there's a terrible driver shortage in many places around the world. But if you eliminate the driver, you also eliminate the driver's brake. So you're taking out one of the key opportunities for charging the truck. The other thing that's happening is automated loading and unloading of trucks at the warehouses. So instead of it taking an hour to forklift in pallets, you have systems which can just completely unload and load the truck in a couple of minutes. So you take away the standing time at the warehouse, which is the other opportunity you have for charging. Now you've got no time when you can charge your truck.
Those technologies aren't solutions for the charging problem. They're going to make it worse. So now we've got trucks that don't stop for driver breaks and warehouses that don't take long enough to unload for a decent top-up charge either. If there's no opportunity to plug in, then how exactly are we meant to keep these trucks moving?
The trick is actually to not have to stop the truck to charge it while it's moving. And the way you do that is by charging in motion, so-called dynamic charging. And we see that all around us. Just over here we're looking at a train line. We can see overhead contact lines. That's how the train gets its power. It comes in from overhead contact lines and just drives the train directly through electric motors. That solution, or something similar to it, is possible for trucks. It's a bit more like a trolley bus or a tram. The solution works very well, been well tested in Germany in particular. And there's a solution, Siemens have a solution that's been running there for about 10 years. The other possibility is to put electrical conductors in the road surface. And there's a solution in Sweden that's like that. So there you have a strip up the middle of the road lane. The strip is intermittent. There's kind of 1 meter sections, plus minus, plus minus, plus minus. You have contacts which reach down to both a plus and a minus. And as you go from strip to strip, the current is rectified, and you always have nice DC current. Contacts that reach down from the truck and contact the strip, and the truck picks up its power from that. And there's a microprocessor every few meters along the road which switches them on and off so that they're never powered unless there is a vehicle over the top. So it's safe. And that little microprocessor also picks up a tag on the vehicle which tells it which vehicle has just sipped electricity from this. So there's a billing system as well. But if you use one or other of those, while the vehicle is in motion, it charges its battery. It has a small battery, maybe 250 kilowatt hour battery instead of 600 kilowatt hour battery in the truck. It can charge that over an hour or two. So it charges at a low current, which is good for the battery. So you get rid of those 3 problems: the payload penalty, the time penalty, and the need to put big chargers into warehouses. So you only have to have a small number, maybe 100 big, really big electricity connections, which power great long lengths of road, each one. So in my opinion, it will be much quicker to roll out a dynamic charging than to do the static alternative.
I remember when I first heard David talking about these technologies, and he does it a lot. Pantographs are a favourite topic of conversation for him. I thought they sounded completely impractical, and that he was totally nuts to consider that this solution was better than battery electric trucks that charge during the driver's breaks. I mean, the cost of installing that kind of infrastructure across thousands of kilometres of road must be massive. And who's going to pay for that? The taxpayer? Yeah, that sounds popular. To be honest, I assumed it was one of those ideas that academics like because the total lifetime cost works out cheaper on paper, but that just ignores real-world challenges. Challenges like standardization, for example. If you've ever had a public EV charger fail because of the wrong plug or app, imagine that kind of frustration, except now you're in a 40-ton truck and you're stuck because the power rails under your wheels aren't compatible with your vehicle's connector. You can't just drive to a different highway. So to get around that, everyone is going to have to agree on the solution, or we'll have to have multiple solutions, which is expensive and inefficient. Not to mention what I said earlier about who on earth is going to pay for all this. I do still think all these huge problems exist, and I don't have immense faith in our ability to solve them, but I've come around to this approach as the least worst. It does solve the hardest problems. No huge batteries, no warehouse megawatt grid connections, and no need to stop for hours to charge. Instead of needing tens of thousands of sites upgraded, you'd need maybe 100 well-chosen freight corridors electrified. There are other approaches too that I don't have time for today in this video, but I might cover in the future. Battery swapping avoids charging time altogether. Just pull into a depot, swap out the depleted battery, and keep going. That's pretty big in China, and Janus Electric is doing it in Australia too. But it only works to the extent that people can agree on standardized packs and vehicle designs, and it's hard to see how that can scale across a whole sector with different manufacturers and fleet needs. Then there are fleet electrification services. Companies like PragmaCharge help operators transition by covering upfront truck and charger costs. It's a useful model for smaller logistics firms, especially those without the capital or in-house expertise to manage the transition. But it doesn't really solve the core issue of when and where to charge a trucks without disrupting operations or adding costs. So that would be at best an as well as and not an instead of solution. I started this video by pushing back on the idea that electric trucking is easy to solve, that we just need a bit more battery range and some chargers at truck stops and warehouses. But I've ended up somewhere I didn't expect, cautiously optimistic about dynamic charging. That doesn't mean I think it's a perfect solution. It's not. Building out pantograph infrastructure or conductive road systems across a freight network is a massive task. And I'm still not convinced that we're capable of coordinating on standards the way this would require. But if we step back and look at the big picture, really think about what a zero emissions freight system would need to look like at scale, it's clear that none of the options are easy. So the real question is, which challenge do we want to solve? Do we want to electrify every warehouse and distribution centre with multi-megawatt grid connections at a time when we're already struggling to connect wind and solar farms fast enough? Or do we want to invest in electrifying a few hundred key freight corridors and figure out how to make that infrastructure work reliably for all trucks? Either way, we're facing a giant problem. Dynamic charging just happens to be the least worst option, and the only one that I've seen that actually aligns with how freight operates. If anywhere can prove that it's possible, maybe it's in the UK. The Centre for Sustainable Road Freight, led by Professor Cebon and other researchers at Cambridge and Heriot-Watt, has modelled how electric road systems could slash battery sizes and costs for freight. They're part of a government-backed trial looking at electrifying a stretch of the M180 using pantograph systems. It's not a committed project yet, but it's a serious research effort focused on real freight routes, and it's exactly the kind of groundwork that needs to happen if we want to solve this problem in time. Hopefully, next time I'm in the UK, I'll be able to take a ride on a batteryless zero-emissions double-decker bus, powered straight from the wires above. Thanks to the Engineering with Rosie Patreon team and YouTube members who support all my videos and chat on the exclusive Discord server about all things energy. We would love to welcome you to the team, and you can join us at the link in the description. Thanks for watching, and I'll see you in the next video.